recording. Bloop. So we're going to be reviewing for the final exam. We don't have a final exam review technically, so we're going to go through the practice quizzes. That's a very healthy decision. What is on the final exam is everything. Like, it is everything from your other exams. I basically copied these question banks, dumped them in here, added the quiz here, and dumped it in, and called it a day. Now, I had to reorder things. I had to combine things to make it down to 21 questions, but a lot of them are, well, they're fairly easy, I think. Yeah.
I do have one question. So in chapter 12, there's a question where we had to find the hanging box problem, where we had to find the angle alpha. Will we expect something like that on the exam, or is it just going to be?
I took it off the first exam, I believe.
Yes.
And then it's not in this one.
Okay.
Yeah.
So anything that wasn't on the first two exams.
Right. Correct. Literally copied those two and put it in here. Yes. So if I had already removed it, I had already curated it. So it's already a nice list.
Okay, that makes me feel a lot more confident.
But its cousin is still there. The wires with the hangy doodad. Would you want me to start going back from the beginning and go forward?
I would absolutely love to.
Okay, cool. And so, I've seen them. Sometimes it's been a while. So, is the concept there or not? That kind of thing. Y'all just tell me as we go. I think most of this is going to be pretty straightforward.
I believe we're on question 12 is where I had started really asking questions.
Right.
A lot of these are just like, oh, where's the center of the sphere?
Yeah. Like, and again, most of these are so simple that I don't know if I wanted to put them on an exam. So like that might be on there, but then the thing is you might get that one or this or this or that kind of thing. But I tried to group them according to difficulty level. So like here, this is an application type problem, so therefore it's a little bit more than the other ones. Not hard. This one's on there. This one's on there for sure. So I think I took like the few of these harder ones and grouped them together because I want a hard one and then an easy one. Everyone, yeah, I can. Yeah, that one. Oh no, not that one because the alpha.
Yeah.
You want me to do it?
If you don't mind.
I would love doing it.
Refresher.
Would you like me to go back and do this one?
That one should just be R cosine R
Yep.
sine. Right?
Yep. I think so because they already give you a speed. So oh, the center of the sphere. So like back here a little bit. No, back. Oh, this one would take a lot more time. Yeah.
So you have to complete the square.
Yeah, I don't remember having that one on there. Was that on there?
On the first exam?
Yeah.
I think no, actually no, it was the multiplying the vectors.
Yeah, I think I didn't have those. I think I started here. Yeah, I'm pretty sure I remember having this.
But if you're curious, it's literally just like with the ones where it's like parentheses, it's whatever numbers next to like eggs.
Yeah.
You flip the sign and that's your center. And then your R is just square root of whatever it's equal to. That's why I was like, I'm sure I'll get it as soon as someone talks through it, but right now I'm like,
Oh yeah, well, we're here for you.
no, you're perfectly good, man. I just started reviewing last night, so I know a couple of these questions.
Are they gonna let me get rid of that? Oops. Are they gonna let me get rid of that bar? That would be nice. Man, what is up with Cal 3 in the bar, man? Anyways, so it's fine. Yeah, this one here, 700, and then cosine 30, 700 sine 30.
Okay.
I don't worry about it. That one's combined with some other ones, but yeah, this one is a little bit longer, and that's fine. So yeah, no, I'm trying to remember. Like Professor freezes up. I don't know. So I need my x components and my y components. So my x's are going to be this guy. Let's just do f1, I guess, because it's in order. So I have f1, and it'll be a cosine of something. And then I have the f2, and then I'm going to have the cosine of something. And then that equals 0. For my y's, I think I have just the signs. So f1 sine, f2 sine. No. You can't do that to me. Oof. It's okay, we got this. F2 sine. And then this equals 400 because it's like the up is equal to the down kind of thing. But what angles do I put in there? That's the thing. So what would be my angle for F1? Oh, really? You are thinking like physics, which is very good because this is in physics. In Mathy land, it's 160, yes. Right, right. And then Mathy land, here I have... Oh, it is 35, you're right. I'm sorry. I was doing some geometry in my head. What? It's not 60 something or 55? No, it's 35. You're right. All right, cool. I want to not spend a lot of time on this, and they want decimals anyways. Desmos. Yeah, Desmos. Exactly. Desmos. So let's do some Desmos action. How I'm going to do this is an x and a y. So x times cosine of 160, y times cosine of 35 equals 0. Correct. The problem is that this is all in radian mode, and so I can switch the mode. So way over here, degree mode, and then I want to know where they intersect. Perfect. At least I hope that's the answer. See, I get nervous because it's almost too easy, right? It's almost automatic. So yeah, 400, 458.86.
Did you just graphify the answer?
I did. You didn't see that?
Sorry, I was copying stuff down.
No problem. I put them both in, and just where do they intersect.
That's very nice.
It is very nice, and it makes it much faster. Again, I'm a little leery because it's almost too easy now. But since I came up with a beautiful 400, I figured that the others are fine. Okay, and then they say, what is the actual like vector amount? So that's going to be, again, the 400 cosine value, and then the 400 sine of the value. But, you simplify, and same thing for that one. Desmos Scientific. Good with that?
Yeah. And just to clarify,
Yeah.
so in the parentheses that you have over on your writing down
Yes.
area, the point is basically the left side is the F1 and the right side is F2.
Yes, that's how I set it up. Yep.
Okay.
If you set it up differently, you get different things, but that's how I set it up. Cool. Does that make sense?
Yes, sir, it does.
Sweet. Is that easy?
Yes, sir, it is. At least I think it is.
A lot faster than doing it by hand.
Yes.
Right.
We have to use a system of equations.
Oh, man. Exactly. Yeah. Yes. Yes, indeed. Cool. So yeah, that's a good thing. Let's see what else we got around here. Yeah, that's fine. Not that one because the angle thing. I don't like that. This one is a yes. So same thing. We're trying to find W and F1. So I'd set it up the same way, X and Y, because Desmos graphing you need X and Y. Did you want me to do it? Yes or no? You gotta say.
They'd be saying it the same formula except we have F2 now, and then you can solve
Right.
for the weight.
Right. It's identical to what we have here. You have a number here, and then you put the W there, so it's equal to Y essentially. Yeah. Same thing. Same thing. Good? Okay, good. This one, no, we didn't want the angles. Like, it would be fine at this point because we got Desmos graphing and all that, but I just keep clicking back and forth. And so, yeah, not the angles. I already said not the angles, but this one's fine. Okay, so let's keep moving, okay? Not the angles. Not the angles. Just... I can't remember if I did this one. I don't remember, but I know that you should have that formula and stuff.
That was on our first exam.
Okay, well then, yes, do it. No, same as the other ones.
So if we basically just prepare for the other two, like
Yeah.
things that are given.
Literally, and then to chapter 16, whatever formulas you've been using. Because there's like, there's so many different formulas in 16, but it's just which ones are useful to you. And I would write them all. And write down the words flux and circulation beside them. Oh my goodness, right? Because they're going to say flux and they put the wrong one, it's all over. Okay, yeah, but I'm not worried about all this stuff. We're looking for hard problems. Angle between vectors is on there for sure. See you later. Oh yeah.
I believe that
Arc cosine.
Yeah, arc cosine then u times v over
Yep.
v.
Magnitude U, magnitude V, yeah.
Oh, I thought it was magnitude v squared. This one, no.
Now you're making me nervous. So, yeah, it's the arc cosine of U dot V over magnitude of U, magnitude of V.
Oh wait, no. What I'm thinking of is the last problem. The projection of v in the direction of u.
You're going to need that.
That one is the, I believe, magnitude v squared times.
Yes, that's correct.
Yeah.
V squared in the bottom, yep. For that one. This one, I believe I mushed with the other one, that velocity one that was the cosine and sine. You see how it's application, but then at the same time, you get the point, right?
Yeah.
So I think this is just sine and cosine again. I can't even remember if it's in the same section, but I grouped them together. This one I think is with that group as well because it's a simple sine or cosine thing. I think it's just, what are they looking for, the cosine of that or sine? I can't remember.
And then I believe it's like the weight times cosine angle, and then something like that.
Right. So so this now is, you said we subtracted it, right? So then that's 32 minus the 18 would make, help me out.
That'd be 17.
16?
Okay, calculator time.
Oh my gosh, calculus 3.
Look, if I could do basic math.
Is it? It's 14. Okay, it's 14. I'm sure of it. It's 14.
It is 14.
Thank you. Anyways, and so they're saying the work done, which it's going this way. Need to find the workforce to make the component parallel. Oh, hold on. Find the force so that the force parallel to it is 2.9. So they're saying that this is 2.9 pounds. And so we're looking for, I believe, the cosine then. Am I right there? So 2.9 is equal to W times cosine of 14. And then I just divide. I think that's what we do. Yes? Yeah. I'm looking at you, bro, because you could teach this class. Yeah. Anyways. Yeah, it's the small things like that whole parallel to the plane. And so that would be your x component, thus cosine. Cool. Yeah, this is another one like that. Can we just... So, okay. I want to find the angle between these two guys. It almost makes me feel like I can just put it into Desmos. I don't think that's going to actually work, though. Don't we need to find the slope between them, the two slopes? I think there's a formula specifically for that, and correct me if I'm wrong. I believe it was like arctan of slope 1 plus slope 2 over something like that. I can't remember. But there's a quick formula for slopes, and then you can just like be done with it. Not recalling that. Oh, was that a different class? Okay. But we can make two vectors, of course, right? So I would say my u and v. Yeah, let's get rid of that. My u and v. I would have 1, 9, and then also my negative 4, 5. I believe that's all I need because. Go ahead. Yeah. And the 8 would drop out, right? T derivative would just go away. So I think that's all we need. So datum, magnitudum, arc cosine. Yeah. Right, arc cosine. You got it. Oh yeah. It's funny, you come back, you're like, oh, now, you know? Yes. Exactly. Same thing here. I'm not worried about it. Okay. Area of a triangle, that stuff is on there for sure. 100% sure this is on there. So I think there's the formulas that you take the cross product of two and dot it with a third in magnitude, cut it in half. Oh, I was thinking the parallelogram. You're right. For a two-dimensional triangle, it's the magnitude of u cross v divided by 2, I believe, for the triangle. My little dot product thing, that was the triple scalar product or something, but that's for parallelogram, which I don't think we have that.
The only thing that I'm not familiar with, or remember at least, the vector, like the scalar vector on this one. That's the only thing I'm a little unsure of with this one.
This thing?
Yeah. I can't remember.
That's the cross product. They're just saying what's the cross product. See, it's perpendicular to this plane. That you're literally just saying which one is the cross product. So I'll do it. I'll do it with you right now. I'll do it, bro.
Okay.
Yeah.
That would help me just refresh on that a little piece that I don't know.
Is there a way that Desmos graphing can do cross products?
Not that I know of. I wish.
I'm gonna search that sometime.
Way to do it on Desmos Scientific, where we set up a formula and then plug in values.
I'm gonna use this as my my R as my origin because it's a little easier. So terminal minus initial, essentially. And then actually because I'm gonna do this cross product stuff, I'm gonna do this, and so this minus that, so 0, 0, negative 2. It's always a 0, 0, and then I've got, this is the negative j, so it'll be a positive 2 in the end. 0, always a 0, positive 2i, and then 0, 0, 0. And so what happens is we have 2, 2, 0 is my cross product. Now, which of these looks the best? Look, IJK, IJK, IJK. Oh. Right? They're both the same. You don't have a K. Of course, if you're doing the normal vector, you just divide by the square root, blah, blah, blah. Right? Good with that? That's all they're asking for. You're having to leave. Oh, okay. Well, your call. I mean, okay. Should I stop? Okay. You're good. Full sheet of paper, front and back. It is beautiful. Yep. Is it gonna make a lot of noise? Like.
He's gonna have abacus, his mechanical calculator, and then a compass. Just a water calculator. Yes.
Well, have fun with physics. I know you'll do well. You know you'll do well. You can do that. Did we do parallelograms?
With that one, you pick one point, and then you do cross product, but you cut out one of the numbers that you're given because it's accounted for.
Yeah. This is because it's the area of a parallelogram. Still area.
It's like the last problem, except for whichever one
You just-
you guys are point, you have to cut out one of the set of numbers.
Right. Essentially, you just get rid of the 2. We can try. We can try. Yeah, geometrically, for sure, you can at least look at it. Let me try to do that. Okay.
You might be able to make a table.
Oh, yeah, make a table. It makes it even easier. It's as if you've done this before.
Only once or twice for a lab or two.
Oh, okay. I wonder if there's a way to find the area there in Desmos land. Well, just a thought, though. Boink, 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 boink. Okay. I'll leave it to you. Y'all know what to do. You just make the triangle and just double it, essentially. Cool. Good. Same thing. Same thing. All of this is on there. Same thing, right? Because it's parallelogram, you don't divide by 2. This one's different, but definitely on there. So distance to a point to a line, and then we got point to a line, and we got point to a plane. I'm sure. Yep. See. So yeah, let's go through some of those if y'all are okay with that.
Yeah, that sounds good.
Great.
I'll be honest, with this stuff, I'm more focused on like the section 12 and 13 that I really need to review on because the 14, 15 we just did, and then 16 we're currently working on. So like 12 and 13 is what I'm really more.
Good. Yeah, it's like a refresher thing, right?
Yeah.
Good. So distance from a point to a line. First off, we probably have a formula.
Yes.
And that makes it a lot faster if we have a formula. Let me just get rid of all that. And swoop. Oh, okay. No. Whatever happens, stop it. Swoop. See you later. You'll do well. Thank you. Section what?
12.5. Actually, funny thing is, since you're on the page with the practice quiz, you can actually hover on the question. It'll tell you which section. So if you hover on the question, it'll tell you 12.5.
Only on the practice quiz?
Yes. And homework. And quiz. Oh.
Did that get out on my recording? It helps. It helps kind of point you in the right direction. Wait. It helps point you in the right direction. Oh! I know, math nerds. Oh, yes. No, yeah, you have to take linear algebra for that.
Okay, fine.
Yeah. Not thinking that you're going to need that here. Where did my... Yes.
That's how I did it.
Yeah. No, it doesn't solve it for you like you're thinking. Okay, there we go. Well, mine too. So distance, we got PS. So I think that's just my my vector, my slope, essentially. And no, what would? So yeah, parallel. Oh, P is the point that I'm looking at, and S, distance from a point to a line through. So point S, and then this is another point on the line parallel to V. That's my slope. Oh yeah. No. I think you're fine. I think V is my slope, and then I need to find 2 points and do terminal minus initial,
Right.
which is not hard. The terminology is weird. So that's why we're practicing, right? P and then S. If I plug in 0, which is very simple to do, you get something like that. And so PS, terminal minus initial, you would get PS. 3 minus that would be a -3. a 4, and then a -2. And then my v is my slopes. So -1, 4, 3. Cross them. Magnitude. Divide by magnitude. Blah, blah, blah. Oh, I don't like doing it like that, though. Go ahead. Right. P is the point, S is on your line. And I just plugged in 0 because it doesn't matter. It's just any point on the line. Plugging in 0 is just super easy. At least I'm pretty sure this is how it works. Yeah. And then you cross product them. If you don't mind, because this one doesn't have a lot of zeros and it will be a mess, can I try and show you an alternative method for cross product? Like using Desmos? A point and another point. Yes, yes, terminal minus initial, exactly. Slopes. Yes. Okay, cool. I'm gonna try to have Desmos do this for me, and it's just scientific, so it's nothing crazy. I probably showed this once before. Let me pull this up over here. So there's a formula for each one of these. But what I need to do is kind of like set it up in a way. Give me a second to think about this. If I did x1, y1, z1. Let me just try this for a second. Y'all gonna hang on for me for a minute? Are we okay with this? Okay, and then I got x2, y2, and you can label it whatever you want. But if this is taking too long, then you don't need to do it. But my I, which like it's just like a letter, not the imaginary, I guess. It would be the determinant of the things that I don't have essentially. Give me a second here to think about it. Oh no. We have a formula. We have a formula for it, and it's kind of weird, but we do have a formula for it. Give me a second. Like this thing. Yeah. Right here. I know that looks weird, but right here at the bottom, that's what I'm actually wanting. So let me do, do they do UVW? Okay, let me erase. I'm going to do this formula right here. And if you write down this formula, then it'll be really easy once you like start getting it all set up. So I need U1, U2, U3. Okay, so I got over here, let me do it again, -3. I know, I'll come back. I just need to rewrite my stuff. Notice that my U's are the first one, my V's are the second one, the second vector. V3 equals 3. Okay, so then I just literally copied this down. So I got U2 V3 minus U3 V2. And then I've got negative U1 V3 minus U3 V1. Notice the negative in the front, very important. And then U1 V2 minus U2 V1. And there's your cross product, you're done. Cool. You have to do a little bit of setup, but if you write down that formula on your formula page, I mean, it's not hard to write that formula down. If you're in a bind, you could use it. Right. Yes. Desmos also makes it nice because you just type U and then a 2 and it already subscripts it for you. You don't have to keep doing subscripty things, so it's easier to type on the keyboard. So like there's some advantages to it. I'm guessing you're writing that down. I'm going to leave it for a minute or two. No rush at all. Yeah. Yeah, it's made for numerics. It's made for numerics. So if you're trying to solve for something, then it's not happy. Yes, you can plug values in. If-
What I mean is, like, if you had more complex ones, you could plug those complex things in by hand and solve it by hand that way. It's not gonna be fast.
Correct. So it's a trade off. I wouldn't recommend this all the time, but it is nice to have. And so then I now need to find the magnitude of that stuff. Since I'm here in Desmos land, might as well. So 20 squared. Get rid of that parentheses so it's prettier. 11 squared, and then 8 squared. There we go. That didn't help me. And when it doesn't help you like that, just get rid of the square root, right? So the magnitude of this stuff would be the square root of 585. And then we could just say, what's the magnitude of the 143? Divide by it, and we're done.
So this question was it was the point to the plane, right?
Point to a line in this case.
Okay.
Yep. So then just divide them and you're good to go. Cool.
Yeah, because I remember what got me on the first exam was like these questions where I got confused with the point to a plane versus point to a line.
Line to a plane and all kind of, plane to a plane. There's a lot of different formulas. So point to a plane. So that's another formula. I think this one's probably the same style. I just want to do a new one. It's almost too easy.
Yeah, those are
Plane to a plane.
I believe those are all just formulas. That
Yes.
cross products.
Mm-hmm.
What cost me the most on the first exam is I just did cross products.
So yeah. Point to a plane. So you would just find a point on the plane. I would say 0, 0, and then solve for z. And then that's like a really easy point. So your PS. N is your slope, so 744. Boom, you're done, essentially. Cool?
Yeah.
And then this guy. Nope. This one here. Plane to a plane.
Wouldn't
There-
that wouldn't just be like placing like finding B and U, which would just be the X, Y, and Z's and then cross products, or am I thinking wrong?
Personally, what I would do is go back to point to a plane, because you could just find a point on this plane and just say point to plane. So here I would say 0, 0, solve for z is 27. So there's your P, and then you could just go and do the same thing you did on the other one. Yeah, so make plane to a plane into point to a plane, and then you're good. But there's also a special formula for that one in particular. I don't know. Up to you.
I remember for this one, the numerator, you always get it by subtracting like the lower number from the higher number. So like subtracting 12 from 27 gives you your numerator.
Right. But exactly that. See, and we probably talked about the concepts of that, where we have a plane and we have another plane, and we want the distance between them. It's super easy just to say, oh, well, it's y value minus y value, right? It's super easy and done. But that's not what they're looking for. They're looking for this guy. So in a way, it is going to be that style, but you can see it's divided by something. So there might be a quick trick to that.
Well, wouldn't that be like like with the triangle, like how you do like for like sine, cosine, tangent, where like the hypotenuse would be the 15, and then you have to divide it by like
The magnitude of the normal vector.
yeah.
So watch this. Isn't that funny? Look at that. Yeah. Yeah, they're laughing. So shortcut, and that's fine because there is a formula for plane to plane. You know, if you know it, then use it.
But I remember it only works in this specific case because both the x, y, and z values are the same.
But if you had two different values for your planes, they wouldn't be parallel and it wouldn't make sense anyways. You're just going to be 0.
Because they fly.
Exactly. So it has to be the same. Therefore, this formula will always work.
So how did you get the 9?
Oh, 3 squared.
Oh yeah. 3 squared, then 1
And then 1 squared was squared, yeah.
Oh, okay. Square. Okay.
Right, magnitude. Yeah.
Take the numerators, divide them, or subtract them.
Yeah.
and Pythagoras on top.
Cool. Yeah, easy stuff. Graphing ones.
That
I-
one, would
I-
that one be a
Bro, I'm not,
ellipsoid?
plug it into Desmos.
Plug it into 3D and flip it.
Yes, I do recommend that.
Oh wait, do we have access to 3D?
Yes, you have anything on Desmos. Yeah,
Now I'm not gonna get a graphic one wrong. Which I've been getting wrong on all my screens.
that's funny. Yes, plug it into Desmos.
Which this should be an ellipsoid of some sort.
Yes. Yeah. Now you still have to be careful about which ellipsoid. I know that here there's only the one, but there's other questions where one side's bigger than another, and you got to be careful. Okay, so don't be overconfident. But graphing is very important to Calculus 3. And then we got ellipsoid, I guess. Yep. Anyways, I think there's 3 of those, and because I couldn't group them because they're in chapter, I think there's a 12, and then there's like a 14 and a 15 or something like that. I couldn't put them together as one single question. So
It could be a mixture of like pick for random or one of those essentially.
it's going to be, well, yeah, the pool for these are enormous. Each one of these is like 50 different options, but like you can go through every one of them here. They're all here. Yes, I believe there's 3, and I couldn't mush them together because they're different chapters. So that's good for you, not for me. Like basically, you get, and I can't remember if I kept the wireframe ones or not. But you will have, I think, 3 graphing questions, which is important. But at the same time, it's good, and you can get it wrong really easily.
I'll be honest, I honestly forgot how many because I think the rest of these questions are just graphing.
Yeah.
About how large this practice quiz was just by graphing.
Right, and that's, I'm not trying to hide anything from you here,
Right.
So yeah, that was good.
'Cause I
So
remember yesterday when we were doing the practice quiz 12, I got to like question 29 and I was getting really late, so I'm like, you know what? I'll come back to it tomorrow, and then I realized now there's another like 30 questions that are just graphing it.
right,
Right.
as much, right,
Still need to be careful of them.
please
Some of
do,
them are a little bit weird how they fill it out.
right, yes, just be careful. I know my math lab, if it had like the spinner stuff and you can like see it easier, that would be way cooler. But we just don't have that. It's free pilot. Are y'all cool taking derivatives?
Yes.
Are you okay plugging 5 in?
Yes. The only thing I would like to talk about is the equation for the path in practical y.
Mm-hmm.
And I was thinking, I see something. I don't know if it's right, but it looks like you can, if you, well, no, that wouldn't be right. Never mind. I was thinking, oh, well, x and y have the t plus 1 in common, but it's t squared.
Is that okay?
You know, sure.
Right, because you move it over to solve for x, or I'm sorry, solve for t, and then you plug it in.
That works for me.
Cool. Cool. Yeah, I'm not too worried about that one. But that is on there. I mean, these kind of any kind of application possible, I try to put it on there because that's a staple there. But I think 13 was very short, so we're not. I think how it worked out. Chapter 12, I think, had 4 or 5 questions. Chapter 13 only had 3 because I just don't have enough content essentially. And then
It'd be like the solve for like t, a, and k out of curiosity on the exam.
there is the cap T. That is true, but I tried to keep it as chill as possible. So I mean, these are there for sure. Just derivatives, right? Not a big deal. Same thing. I'm sure that you can take a derivative. Yep, graphing. And I can't take that away. I need graphing. So
It shouldn't be as bad because we have Desmos 3D, which we can just graph it. In this
well,
case.
here's the thing. Do you know how to put that parametric in? That's going to be my question to you. So not bad, but you have to be prepared on how to use it, right? You have to know how to use your tools. See how I'm doing parentheses and stuff?
Yes, sir.
0, and then this is where it says more than whatever. So if you just did like 100, and you zoom out, you could see what's kind of going on. So then spiral this guy. Cool. I know that's a little. Yes. Yes, that's true, actually. You see that. Very good. Well, here at least you can rotate it. Oh, that looks pretty cool. Seizure. So, but yeah. Stop it. Okay. So, anyways, it is cool, but you have to know how to do it, right? You have to do parametric in a certain way. So maybe you write notes about that and say, I need to use parentheses or whatever you do. This stuff is on there, but it's all grouped together with like a lot of derivatives and stuff because it's just too easy.
Just
Yeah.
questioning if
Yeah.
I'm thinking the right thing. It's just taking basically the integral of I and then I and split, like just sticking it in.
Yeah, just 3 integrals.
Okay,
Yeah, just 3 integrals.
that's what I assumed. So I figured I'd just ask it.
And so, like, what? Yeah. So, what's the integral of secant squared tangent? I already know you know it, but I can't remember if I kept that because I know we knew it or not. Whatever was on the first exam, it's on there. If it's not like sine squared, did I get scared or did I tell you there was a formula for it?
Yeah,
Probably
you
a
had that
formula.
told us specifically to write down first exam.
Right. This is on there for sure. But see how this is almost grouped with all the other ones I just did because they're all about the same difficulty. I'm going to do an integral and you say plus c. It's not that bad. I mean, that one in particular. When you integrate this guy, don't you get ln?
Wouldn't that be an arc tangent?
No, that would be t squared.
Oh, right.
I believe.
You're absolutely right.
It's like u sub,
Yeah.
but it's like really easy u sub. Yeah. Anyways, I know it looks difficult, but if this is on there, I don't think I got that one on there. I think I removed it. If it was formula driven and you forgot the formula, I felt bad, so I probably removed it. This is on there for sure, but see how it's application. So I try to keep it with the other application problems. So this one might be grouped like the first ones we did in this chapter.
Which I believe this one is like the
Oh, that we have formulas for that.
yes. But this one it's x naught plus velocity naught times cosine theta times t, and then the y would have y naught plus velocity sine, and then it would be gravity times t, something like that. Hey, there you go, right there. What I'm talking about is the top formula.
Right.
Yeah.
So yeah, I would say just write them down, toss it in. You've done them before, but practice, of course, practice on it. Same kind of stuff here. It's not that big a deal, really. Same thing here. We can do this without these formulas, but the formulas make it faster. So this is on there for sure. But again, it's not going to be cap n or anything crazy. There is going to be a difficult one. I think I grouped these difficult ones together, so I wouldn't have put this one with something that was super easy. So
If I remember correctly, the equation for t would basically be taking the derivative of r, so you get v, and then you would take the magnitude of v, and then put that
yeah,
vector v over the magnitude v. That would get you your
Yeah.
answer for t.
there you go. This guy. Yeah, it's not too bad. Yeah. And when you say that now, it's because you've been through chapter 16. You're like, oh man, that one's not too bad. Notice again, this one's because it doesn't have a J. Watch out for that. And you have the formulas here now that you can, well, sorry, these are derivatives. So yeah, make sure you're taking derivatives when you need to take derivatives. Because I see, oh, I got a formula for that. No. Stop, just stop. But you can see most of them are pretty straightforward. Like, same thing. Right.
And this, I believe, is part right? Where you just do that formula.
Oh, well, there we go. There's all the fun stuff. Like, I can't remember if we had curvature, but this is one of my favorite formulas for curvature. Okay, good. So just saying, it's a little bit more straightforward. If they say curvature and it's 2D, just pop that one in. Yeah, don't we have an arc length formula somewhere? I think this is on there as well, but we haven't got there yet. Arc length? Didn't we have arc length somewhere? Is that in a previous section? I can't remember. Oh, there it is. Oh, look. Haven't we been doing that in chapter 16 all the time?
If I remember correctly, Z in this case would just always be 1.
If it's 2D,
If it's 2D.
yeah. None of this cap end stuff. None of that's on there. It's too much for one problem. It's not worth it. So, yeah.
That makes me feel a bit better. 'Cause
Well, I mean, you
remember-
knew that though.
Yeah.
That was from the first exam. This is on there. This is on there. But I wanted nice ones. So you got to have the formulas. I don't personally like these problems, but that doesn't mean I can't talk about them. So I think we're just taking the derivative right here of the magnitude of v.
I believe also there's a formula for it.
Yeah.
I find it a lot faster as well.
Yeah, there's a formula. Yeah.
Because I remember I had that written on my note card just for like this type of question specific.
Do you want me to do it?
Sure, actually, yeah.
Cool. I can't remember how to do it, so here we go. So my v, I definitely am going to need that. So that would be the 2, the 1, and the -5. And then I'm supposed to, let me go back to my formula, is take the derivative of that, of the magnitude of that. So magnitude of v, well, it's a scalar now. 4, 1, 25. So that would be square root 30. I'm supposed to take the derivative of that? Just a 0. Right? Well, there are zeros for here. But because one is 0, I think the other one's like the full length. But I can't remember the formula. Let me go to this formula book right quick. So I'm using the one from the lab. So this has like all the formulas. And I think that there's a quicker version of this one in particular. Oh, right. Oh, yes. Let me remind you here. Here's the two formulas. So we have v dot a over magnitude of v, and then an is magnitude of a, or v cross a over magnitude of v. I wonder. Oh, this is definitely 0 because if you took the derivative of this guy, you found a. Exactly. So regardless, that one for sure we can confirm that's a 0 with or without that other formula. But actually, what's interesting is if I cross a 0 here, wouldn't I also get a 0? This is a possible answer. I wouldn't just go and guess 0 just when I see it. But I mean, you know, it could be. So yeah, confirmed. 0, and even that other one is 0. I guess that kind of makes sense. We're talking about the tangential and normal components of acceleration. And basically, I'm traveling in a straight line, and they're wanting to know, hey, as you're making a curve, how much force do you have in these two directions? That's what it's coming down to. Well, I'm not making a curve, so none.
So we're finding the normal. Yeah, okay.
Right. It's like when you're spinning something and it makes all that.
It's kind of funny because you can tell that.
Yeah, centripetal.
You can tell that well because the t values are only to 1 power, so you know it's going to be a line of some sort.
Right.
Yeah.
Exactly. So I can't even get to A. A is going to be 0.
A is the derivative of v. Yeah.
Yes.
Yeah, it's acceleration.
Yeah.
Putting it in the terms of physics actually helps me.
Good. Good. It should. That's a good thing.
I need something to grab on.
So repeat. You can see that we will have something to talk about. But I'm not worried about that. It's the same formulas. Just write those two formulas down. Those are the formulas that we need. Not equal 0, by the way. They're not equal to 0. But in our case, it was. It was just that these are the formulas. Cool? Oh, that's a good point, actually. A little bit more hefty. Can't remember if I kept the hefty one on there. Ooh. Anyways, yeah, I can't remember. It's going to be simple, easier ones on the exam. If it is on there, what happens is that when you do this, they cancel. Everything cancels, and it makes it a lot faster. You'll see, but I'm not worried about it. I don't think that's on there. Are you good with this?
Yeah, because with this one, you take the derivative, e to the t is always going to be that, except for the one where it's sine t and cosine t. That's going to switch up, and then that's going to be
You're also gonna have like e to the t sine t
yeah.
plus e to the t negative cosine.
I don't think it's on there. Well, I mean, I don't like because it's too much compared to the other ones. Like, say this one's on there. So, are you going to get this one, or are you going to get this one? Who's actually getting a good deal out of this? You know what I mean?
Because I know the math, but it's like so much. It's gonna feel like a page.
Right. And you keep wondering why does Mason keep doing so well in the class, but Ryan does not. I mean, that's not the case.
That's not the case.
Not the case, but the point is that would be unfortunate. I don't like that. It's not fair.
Mason does so well because he doesn't sleep.
Well, I guess he does. He's a busy person. That's true. It is 11:30. We can keep going, or because we just finished, we can stop here and come back tomorrow.
I mean, we covered 2 chapters. I'd just say so that because we're going to be reviewing until Wednesday, so we can do like 2 tomorrow and then
Yeah.
Wednesday.
Sure. Whatever you want. Is that good for y'all?
That works well for me.
Okay.
Well,